fellow Toastmasters, and welcome guests. Tonight it is my pleasure to present to you my second speech. You know. So everybody has in front of you your ballots for the evening. I want everyone to hold up your ballot sheets. Everybody, this is a participatory speech. I need everyone to do this. Everyone hold up your ballots. Great. Now, before you write my name on the best speaker, I want you to flip it over. And I want everybody to draw me a picture of a raindrop. Everybody draw me a picture of what a raindrop looks like falling through the sky. It's not a trick question. I really want you to draw what you think a raindrop looks like. Some of you are thinking way too much into this. All right. Most of you are probably going to draw something like this, right? This is what I would draw. Who drew something like this? A raindrop falling through the sky. Who drew something different? Anybody? Who drew something not this? Let me see what you drew. You drew the raindrop. That's close, very close. Okay, very close. But everybody, I mean, you're basically drawing some version of this, right? This is a teardrop shape. Turns out it's a very aerodynamic shape. It's kind of what everybody thinks when they think of a raindrop falling from the sky. And this would be great if water wasn't liquid. Think about it. Water is fluid. What does fluid mean? Fluid means something that's always in motion, something that's easy to change. What happens when a raindrop is falling? Well, that wind is pushing up on it, right? Well, if wind is pushing up on something that's fluid, something that can move, something that can change, how long is that shape going to stay that shape? Think about it. You're pushing upwards onto this. It's going to start pushing that water up. Turns out a raindrop falling from the sky looks more like this. What do you know? If you think about it, it makes perfect sense. If you think about it, but we've never thought about what a raindrop actually looks like. And this has all kinds of interesting side effects or interesting connotations. Because if you think about a raindrop falling through the sky, you probably think a raindrop is going to fall on a straight line. Or maybe we've seen storms that are very windy, rain's maybe falling at an angle, but a raindrop actually, with this shape, doesn't do any of that stuff. The raindrop will actually form this shape, and it kind of will slide over to the side because now it's no longer aerodynamic, and it will kind of form the shape again, and it will slide over to the side again. A raindrop falling looks more like this. What do you know? All right, so everyone take your ballot sheets, your raindrop sheets. We're going to try this again. I want everybody now to draw an atom. A helium atom, hydrogen atom, plutonium if you're really super smart advanced. But everybody draw an atom. You remember what an atom looked like? What you were taught an atom looked like? Just try. Give it a shot. Some people are shaking their heads. Just whatever you got. All right. Most people are going to draw something like that. You go on Google and type in an atom, you're going to get some form of that, right? If you're really super smart and you remember physics, you might draw something like this, which was the levels of the electrons, and you learned that electrons kind of operate under orders of magnitude. But let me ask you this. Who drew something other than this? Did you draw something different? What did you draw? That's pretty close. Who else? Anyone else? All right. So, this is good. I'm glad. Thank you for that, because I'm glad somebody actually got to challenge us a little bit. This is all well and good if an electron is a particle. A lot of people think of electrons as these kind of balls flying through the air. That's what we were taught in school. I was taught this in 8th grade, which was 1995, maybe. This is what I was taught an electron or an atom looked like. But an electron doesn't actually exist as a particle. Electrons exist as waves. Quantum theory teaches us that an electron actually exists in multiple locations all at the same time. Only the act of actually looking at the electron causes it to occupy a specific space. An atom looks more like this. This is what an atom actually looks like, or this is more of an accurate representation of what an atom looks like. What you're looking at, this is probably a hydrogen atom. What you're looking at is what's known as the electron cloud. And this is all of the places that an electron is likely to be found if you go looking for it. But until you go looking for it, this electron can be anywhere. And the darker areas are where the electrons probably could congregate. You know, you see this one here that has a dark ring right there. You're more likely to find an electron there, but truthfully, that electron can be anywhere. Something else we think about, you know, all these pictures, these electrons are in rings. they're orbiting around this nucleus like planets. Or we've got these rings. If you get these big fancy electrons, they go up and up and up, and you have all these rings. Electrons actually form these incredible shapes. These clouds are all kinds of different spectacular shapes. Here's one. This is one of the higher levels, but they form these fascinating balls of potential energy. And it turns out, well, apparently, most people don't know what an atom looks like. Most people don't know what an electron looks like. So the question is, when you walked in here, what did you believe? And we believed a drop of water looked something like that, right? When we walked in here, most of us believed that's what a drop of water looked like. Most of us, when we walked in here, probably believed an atom looked like that. Very a little bit closer to reality as far as that goes. I don't know if that's what you were thinking or not when you drew that, but no. Yeah, sorry.
Because I was figuring out, if you actually looked at one, what would you see?
Well, if you actually looked at one, what you're going to see is just a point. Just a little tiny point. Because that's in that moment where that electron existed. If you looked at it again, it's going to be different, every time you look at it. So we'll go that whole way. But so the question, there we go, click it. What do you know? Right? We all believe certain things about the way this world works. We believed what we thought a raindrop looked like. We believed what an atom looked like. And this is important. A lot of you are probably thinking, why do I take it? Because we make decisions as humans all the time based on what we believe to be true. We make decisions about who to talk to because we believe in their ability to help us. We believe in their social standing. We believe certain things about their level of intelligence, and we make decisions. We decide who to vote for because of what we believe they represent or what they believe they represent. We make decisions on going to war based on what we believe about intelligence we have. But the world isn't really about what we believe, it's about what we know. And so my question to all of you Toastmasters tonight is, what do you know? Thank you very much, Mr. Toastmaster.